In the last video, that each element comes in a number of different forms called isotopes, each of which has the same number of protons but a different number of neutrons. Importantly though, only one or two of an element's isotopes are stable, while the rest of them are unstable, and so can undergo radioactive decay, which is where they emit something so that they can change slightly and become more stable. So when we say that a material is radioactive, all we mean is that it consists of unstable isotopes that can decay. In this video, we're going to take a closer look at the four types of nuclear radiation, namely alpha particles, beta particles, gamma rays, and neutrons. And we'll cover how ionizing and how penetrating each of them are. Let's start with alpha radiation. Alpha particles are made up of 2 protons and 2 neutrons, which is exactly the same as the nucleus of a helium atom. So we normally represent alpha particles with helium's nuclear symbol, He. Importantly though, alpha particles don't have any electrons, so they have an overall charge of 2+ from those 2 positive protons. Because they are relatively large, alpha particles are easily stopped by collisions with other molecules, which means that they can't penetrate very far into other materials. In fact, they can only travel a few centimeters in the air, and are absorbed by a single sheet of paper. However, their large size and their strong charge does make them very strongly ionizing, which just means they can easily knock electrons off any atoms that they collide with. Next up, we have beta particles, which are just electrons. So they have a charge of -1 and virtually no mass. Now, the weird thing is that electrons aren't emitted from one of the atom's shells. Instead, one of the atom's neutrons decays into a proton and an electron. The proton stays in the nucleus, but the electron is emitted out at high speed. Because beta particles are pretty tiny, they are moderately ionizing, and they penetrate moderately far into materials. For example, it would take several meters of air, or about 5 millimeters of aluminium to stop them. Now, gamma rays aren't particles at all. They're actually waves of electromagnetic radiation, like light is. And they're often emitted after alpha or beta radiation, as a way of the nucleus getting rid of a bit of extra energy. As they don't have any mass or charge, they tend to pass straight through materials, rather than colliding with any of the atoms, which makes them only weakly ionizing. This means that they can penetrate really far into materials before being stopped, so can travel long distances through air, and it takes thick sheets of lead or multiple meters of concrete to stop them. The last type of radiation we need to look at is the emission of a neutron, and there really isn't much to know. If a nucleus contains too many neutrons, which is making it unstable, it can just throw out a neutron to increase its stability. So to quickly recap, alpha particles are made up of 2 protons and 2 neutrons, and will be stopped by a single sheet of paper. Beta particles are just an electron, and can be stopped by a thin sheet of aluminium. And gamma rays are electromagnetic waves, which require a thick piece of lead to stop them. That's everything for this video though. So if you found it useful, then do give us a like and subscribe, and I'll see you next time.